Hello Math 2 and welcome to week number 2. We're going to be dealing with functions and we're going to be dealing with functions for the rest of the semester. Let's get started. So by way of example, let's say that we have a function. So this is function notation. This is not multiplication. This is saying the name of the function is f and its variable is x. And as the first example, I'm going to use an x squared minus a 2x and plus a 4. And then if we do things like, what is f of 2? So that means every place there used to be an x, now substitute a 2. So this one is going to become 2 squared minus 2 times 2 plus 4. And what does that equal? Well, 2 squared is 4. 2 times 2 is 4. And plus a 4. So a positive 4 and a negative 4 will cancel, so that means that the answer is a 4. Then you can even substitute things like f of, let's go with negative 5. So substitute a negative 5 right here and substitute a negative 5 right here. Since this is saying the whole thing is being squared, then I'm going to put parentheses. So negative 5 squared minus 2, and then replace the x with negative 5, and then there's a plus 4 at the end. So negative 5 squared, this is going to be a positive 25. So this literally means take a negative 5 in parentheses times the exact same thing again, and then a negative times negative will be a positive 25. Now, the reason I'm emphasizing that is because sometimes people will put that in the calculator and they'll say, if you have a negative 5 and square it, Mr. Perkins, you get a negative 25. And I would say, yes, that is true, because you forgot to use parentheses. If you use parentheses, like what this says, and you square it, then you get a 25. So without the parentheses, the negative does not get squared, and the answer is negative. But this is with parentheses, so with parentheses, negative 5 times negative 5 is positive 25. I'm positive about that. And then right here, there's going to be negative times negative, so that's positive 10, and then plus a 4. So 25 and 10 is going to be 35, with 4 more is 39. So now we're going to use the same function, but then substitute something else. So this would be part C. What is f of 7w? So now every place there was an x, put a 7w with parentheses and a 7w with parentheses. So a 7w is going to get squared minus 2 times a 7w and then plus a 4. So this means both of these things need to be squared. 7 squared is 7 times 7, 49, and then the w gets squared. In here, a negative 2 times a 7 will be negative 14 times w, and then plus the 4. And there are no terms to combine, so that one is finished right there. Then on to part D. What is f of x plus 2 minus f of 2? And this type of problem we're going to be doing quite a bit because this is the beginning of finding the slope. And slope is extremely important because slope not only tells you, for example, if a line is going up, it has positive slope. If a line's going down, it has negative slope. If you're in your car and you go from 50 miles an hour to 60 miles an hour, that's a difference of 10. That's also telling you you're going at a slope of 10. So slope is used in a lot of different ways. This is just the beginning of it, because this is a y value minus a y value, and if we divide that by an x value minus an x value, then we'll have slope. But let's do this first. So this is saying, first of all, replace the x's with parentheses x plus 2. So for this one, it's going to look like parenthesis x plus 2 gets squared. That's that part. Then put the parentheses x plus 2 right here. So minus 2 times parentheses x plus 2. And then there's the plus 4. Okay, this part is done. Now we need to go minus. And because the minus applies to everything that comes after it, then you should put parentheses or brackets. I'll use red parenthesis. Now substitute a 2 in for these x's. So we'd have 2 squared minus 2 times 2, and then plus 4. On this one, I don't really have to use parentheses because there's no negative sign to worry about. So you could put parentheses, but you don't have to. It means the same thing. All right, now we need to do algebra to simplify this. So for this one, that literally means take x plus 2 times x plus 2. And I'll do that in a moment. And then I also need to distribute the negative 2. So that means there's going to be negative 2x, and then negative 2 times 2 is negative 4. And then copy down this plus 4, and then minus, and what's inside the red parentheses? Well, this number would be 4 minus, this number would be 4 plus 4. So these cancel, and we just get a 4 from that 4 right there being left over. And then we could multiply this out. So if you multiply x times x, that's x squared. Multiply x times 2, that's plus 2x. Then distribute the 2, which means there's another plus 2x. And finally, 2 times 2 is going to be plus a 4. That takes care of this part. Then just copy this part down, minus 2x. Right here, a negative 4 and a positive 4, they're going to cancel each other out. And what's left is minus the 4. Okay, we're almost done. We just need to simplify. Well, in here, I can see there's a positive 4 and a negative 4, so they're going to cancel. There's a positive 2x and a minus 2x, so they're going to cancel. And all that's left is x squared plus 2x. So then that is the answer. Now let me just show you part D real quick. Part E real quick. So if you do the slope formula, it would go f of x plus 2 minus f of 2. So this is basically y2 minus y1. And then divided by, now subtract this x value from this x value. So you go x plus 2 minus the 2. And that is slope formula. y2 minus y1 over, or actually I'm doing y1 minus y2 and x1 minus x2. But either way, it's slope. And because I already did the top part for part D, then I can just take that answer and say the top part, I'm not going to redo that work because I already did that work. That is x squared plus 2x. And on the bottom, these 2's are going to cancel. So all that's left is an x. And then this could be simplified because this has an x in it and this has an x in it. So that means I could factor out an x. And when you do, this would just be an x and this would just be plus 2. And then for the last step, just get a nice red pen and say cancel, cancel, and the answer is x plus 2. So very soon we're going to be using what's called the derivative, and that's a way to find the slope. And like I said, slope is used in a lot of different ways. Okay, then on to the next one. Oh, actually, I wanted to do another part with that. So I guess it would be part F, but I should write down the function again. That was x squared minus 2x plus 4. And this next part I want to do is graph it. So if you use the graphing calculator, which I often do, you can go to the y equals and then clear out this old problem and type in the new one. So x is squared minus 2x and plus 4. And then go to zoom number 6. Zoom standard is a great place to start. And you should see a parabola. And that is the parabola. So it basically looks like this. And then this point right here is the lowest point of the parabola. That is called the vertex. So basically the turning around point on a parabola is called the vertex. If the parabola happens to be shaped like this, then the vertex is at the top. So it's either the very top point or the very bottom point on a parabola. Those are both called the vertex. And what I want to show you is an easy, fun way to find out where the vertex is. So when you do the quadratic formula, you would say the number in front of x squared is a, and this is 1 times x squared, so a equals 1. The number in front of the x is b, so b equals negative 2, and then the constant is c. And then you could do the quadratic formula. But this is just the very beginning of the quadratic formula. So the quadratic formula goes negative b, and then plus or minus the square root of the b squared minus 4ac. Okay, I'm saying that real fast because we don't even need it. Don't do that part. And then the whole thing is divided by 2a. So this little shortcut formula will show you where the vertex is. Very nice, easy, fun. So x equals, so it starts with a negative, and then you put the b, which in this case happens to be a negative 2, and then it's divided by 2 times a. So these two negatives will cancel. After that, the 2's are going to cancel, and it just leaves 1 divided by 1, so x equals 1. And then if I check my work, go back to the graph, put trace, and type in a 1. So it's going to say x equals 1, and sure enough, that's the vertex. So the vertex is at 1, 3. So then in applications and things like that, so maybe this is a company's revenue, and so it's been going down, and then it's going to reach a low point. Maybe this is in January when they only have $3,000 in sales, and then February and March, the sales are going to start going back up. All right, on to a different type of function. That's a rational function, and rational just means fraction. So it's based on the word ratio, which refers to fraction. So for example number 2, suppose that the function is 1 over x minus 4. Now, if you have 0 divided by a 9, that equals 0. But if you have a 9 divided by a 0, that is undefined. You cannot divide by 0. So in this one, if the bottom equals 0, it's going to be undefined. So in other words, we cannot have the bottom equal to 0. Emphasis on not, because that's going to make it undefined. And then if you just add 4 to both sides, then you'll find out that we cannot have x equals 4. And watch what happens to the graph. So put second quit to get rid of that, and then go to y equals and clear out the old problem, and then 1 divided by, and the calculator needs to know that all of this is in the denominator, so I need to put parentheses, x minus 4. And then go to the graph. So zoom, number 6. And then you'll see the graph is fine until you get to 4. And at 4, there's this split in the graph. And if I trace and I try to plug in a 4, the calculator is going to say there's a blank there. It does not exist because it's causing division by 0 when x equals 4. So the graph basically looks like, here's my x and y axis. Here's the number 4 on the x-axis. And on paper, to indicate that the graph is undefined, so right here, the calculator just said a blank. But on paper, what we do is write a dotted line, a vertical dotted line. And that vertical dotted line is called an asymptote. Asymptote. So that's where the function is undefined. And then the left side went like this, and it's going down to negative infinity. And then the right side went like this, and this side's going up to positive infinity. Okay, so you can write this in words. You can also say that the domain, which means what are the possible x's. So there's a couple of ways to write it. You can say x cannot equal 4. On the homework, if they ask you for the interval notation, so if they ask for the interval notation, that's basically saying if you look at the number line, so this number line right here, and 4 is not possible, so a little sad face right there. So everything else is fine. All of these numbers are fine because the graph exists. And all of these numbers are fine because over here the graph exists. But it does not exist at 4. So the interval notation goes like this. Way over here on the left somewhere, there's negative infinity. So if you go from negative infinity to 4, all of that's fine. And on this side, way over here is positive infinity. So going from 4 to positive infinity is fine. And then the way you say it cannot equal 4 is you put a round parenthesis. And then finally, you just put a union in between, saying it's this side and also this side. So union them up, but do not include the 4. If you were including a number, then you would put a square bracket. So for example, from 5 to 6 is fine. So I could put square brackets. The function exists from 5 to 6. But if you don't want to include a number, then you put the round parenthesis. So that's interval notation. The next idea is called the vertical line test. And the idea behind the vertical line test is functions should behave rationally. So for example, if you ask me, today happens to be a Thursday, you ask me on Thursday, how much is 2 times 3? And I say, oh yeah, 2 times 3, let me figure that out, it's 6. And then you come back on Saturday and you say, hey, Mr. Perkins, I forgot, how much is 2 times 3? And I go, 2 times 3 is negative 19. Well, that does not make any sense. If you ask the same question in math, you have to get the same answer. You can't get different answers. So the same thing has to be true with functions. If you plug in 1x, like a 2, or maybe the function was 2 times x and you're plugging in the 3. But if you plug in the same numbers, you have to get the same answer. So basically that means that if you have an x value and you tell it, okay, if I plug in a 3 for x, then the answer is going to be 6. If I mess up, or in other words, if it's not a function, you ask it, hey, when you use an x, what's the answer? 6. Another time you say, hey, when you use x, what's the answer? Negative 19. Then that is not right. Well, if that happens, you could draw a vertical line and it's going to hit the graph twice. Once right there, once right there. So if the line hits the graph twice, it's not a function. So just real quick, what about a parabola? If I make an upside down parabola. So anytime you make a vertical line, it only hits once. Draw a vertical line, it only hits once. Draw a vertical line, it only hits once. So this passes the vertical line test. Then what if you made the parabola go sideways? Then this one fails the vertical line test. If you can draw a vertical line one time and it hits twice, this fails the vertical line test. So that means this is not a function. All right, that's the idea of the vertical line test. If it only hits once, then it passes, and yes, it's a function. If you can draw a vertical line and it hits twice, then no, that's not a function. The next idea is the domain of a function. And that means, what are the possible x's? And then right there, I just said the input values because who knows, maybe they're not using x for their variable, maybe they're using t. So all possible input values. And most of the time, that's x's. So there's basically two rules for finding the domain. One rule is no division by 0. So like I showed on the calculator, 9 divided by 0 is undefined. So no division by 0. And the other is no square root of a negative. So when you take the square root of a negative, so if you do square root and then you put 4, the answer? 2, not a problem. If you put second square root and you do negative 4, then that says no, that's not even a real number. So those are the two rules. No division by 0 and no square root of a negative. So for the next example, let's say the function is y equals the square root of 5 minus x. With this one, we don't even have to worry about the first rule because this doesn't even have division. But it does have square root, so that means that we can't have negatives inside of the square root. So that means whatever's inside the square root needs to be bigger than or equal to 0. So when you have a square root, then just take whatever's inside the square root and say it has to be bigger than or equal to 0. And now I need to solve for x. So I could subtract 5 from both sides. It's going to leave negative x is bigger than or equal to negative 5. And now to get rid of this negative, so I just have x, I could multiply by a negative 1 or divide by a negative 1. They both give you the same result, so I'm going to do this. Divide by negative 1. Then the negatives cancel and the negatives cancel. So I just get x on this side and 5 on this side. Now, one important thing is when you have an inequality and you multiply by a negative or divide by a negative, it's going to switch the direction of the inequality. So it's going to be less than or equal to 5. So that's the domain. x has to be less than or equal to 5. And then if you're asked for the interval notation, so 5, let's say, is right here. Less than means to the left. So to the left of 5, all of these are perfectly fine. So way over here is negative infinity. Up until 5, all of these numbers are fine. So from negative infinity to 5 is fine. And because this has an equals, that means that the 5 is acceptable. So that means you put a square bracket, and that's the domain. And before we go on to the next one, I just want to graph this real quick and show you. So when I graph it, to the left of 5, the graph should exist. To the right of 5, the graph should not exist. Let's see if I did it right. So let me erase this old one and then put second the square root 5 minus x. And then zoom number 6. So then you could see here's 5. And if you go to the left of 5, the graph exists. If you go to the right of 5, there's nothing. So then finally for this one, the actual graph goes like this. So for the next example, suppose we have y equals negative x squared plus 5x plus 1. Because it has x squared, it's a parabola. And because it has a minus, that means it's an upside down parabola. So even without the graphing calculator, I know that the graph looks something like this. And if you use the quadratic formula, you're going to get two solutions, and the quadratic formula would tell you this answer and this answer. And if you remember, the fast way to find the vertex is use this little formula, negative b over 2a, and then that's going to be what x equals for the vertex. Well, we've done those using math before, but now let's do that with the calculator. So I was specifically looking at the homework, and they do ask you to do this with a calculator as well. So graph this function, clear out that one, make sure you put the negative. X is squared plus 5x plus 1. And the graph should look like this. Yeah, pretty close. I think I should have had this point a little bit farther over, but that's basically it. So how do you find this and this and this using the calculator? So this right here is called, so these two, they have several names. They're called the x-intercepts. So it might say find the x-intercepts, either using the quadratic formula or the calculator. They're still called x-intercepts. They're also called the roots. And root is just a general term to say when you solve an equation, what's your answer? And then they're also called the zeros. Because right here y equals 0 and right here y equals 0. So these are all the three different names for the same thing. So I'm going to find this one using the calculator. Let me see. Just as a guess, this is x equals 1, 2, 3, 4, 5. So this answer right here is between 5 and 6. In order to find it right here, use calculate. So you do need to put second, calculate, and they're calling it the 0. So do number 2. And then pick a number on the left. So like I said, this one right here, it's between 5 and 6. So I'm going to pick 5. So this is saying pick a number on the left, 5, and then hit enter. Now pick a number on the right, which is 6, and hit enter. And then put a guess. And your guess does not have to be very good. 5.5, that's my guess. And it says, well, your guess was okay, but it's actually 5.193. So this one is x equals 5.193. Now let's find this one. So again, go to second calculate, number 2, find the 0, And I could type in numbers like I did last time. You can also move the cursor until it's a little bit to the left, hit enter, go a little bit to the right, hit enter, and then move the cursor sort of close to where you think the answer is. And that right there isn't even that close, but the calculator will find it as long as you're sort of close. And it found it, and it is x equals negative 0.193. Okay, so those are the two x-intercepts. Now for the vertex. Well, we do have this little shortcut formula, so negative b over 2a. So that's the b, so that's going to be negative 5. And then the a right here is a negative 1. So over 2 times a negative 1. So in here, the negatives are going to cancel. And so that means that x is 5 divided by 2. So I can just tell the calculator, go to trace and put in a 5 divided by 2. And it says that the vertex is 2.5 and the y value is 7.25. So there's all the information that we needed for that one. Then there's a couple more things to do. So I showed you some examples where we do the interval notation. So for the next example, solve an inequality 2x plus 5 less than 1 and put the answer in interval notation. All right, so we basically do algebra to isolate the x first. Start by subtracting 5 on both sides. So this side will still have the 2x. These are going to cancel. And then a 1 minus a 5 is a negative 4. One more step of algebra. To solve for x, divide by 2 and divide by 2. When you multiply or divide by a negative, you do need to switch this. But if you're using a positive, you don't have to switch it. So then it's going to say x is less than, and on the right side, that's a negative 2. So in other words, if you look at a number line, let's say negative 2 is right here. This is saying go to the left, and that is where the solutions are, to the left of negative 2. So way over here is negative infinity. So as an interval, this means go from negative infinity to negative 2. And this does not have the equals on it, so I used the round parenthesis. If it said less than or equal, then I would have used the square bracket. So square bracket goes when there's an equals, and when there's not an equals under there, then you use the round parenthesis. And then, just two more, hold on. And then what if we do the same thing, but it was something like x squared minus 8x is bigger than 0. So with x being squared, that means there's 2 solutions. The last one only had 1 solution. This one has 2. And what I could do is factor this. So I could factor out an x, because this has an x and this has an x. So you could factor out x, and then it would leave x minus 8. And what I'm going to do is, just for the moment, pretend that it's an equal 0, and then I'll change it back to this after I solve for x. So after it's factored, then separate into 2 problems. Put the first factor equal to 0, and put the second one equal to 0. So this one is already done, x equals 0. And for this one, you would just add 8 to both sides. So x equals positive 8. Now when you have 2 solutions, when you're looking at the number line, here would be x equals 0, and over here would be x equals 8. And because we have 2 solutions, that means that we actually have 3 intervals. 1, 2, and 3. And I have to see which of these intervals makes the original problem true. So what you do is you pick a number that's in the interval, like over here, -1. You take the -1 and plug it into the original problem. So that would be -1 is squared minus 8 times -1. Is that bigger than 0? True or false? Well, let's see. -1 squared means -1 times -1, so that's +1. A negative times a negative is a +8. And then it's saying, is 9 a number that's bigger than 0? That is true. 9 is bigger than 0. Would you rather have $9 or $0? Yes, 9 is greater than 0. So all of this makes it true. Then pick a number over here, and you can pick any number between 0 and 8. Probably the easiest would be a 1, and substitute that back into the original problem for these x's. So that's going to be 1 squared minus 8 times 1. Is that bigger than 0? 1 squared would be 1, and 1 minus 8, is that bigger than 0? Well, that's -7. And bigger than 0 is another way to say positive. So is -7 a positive number? That is false. So all of the numbers in here are going to make it false. When you have a polynomial, they will alternate. True, false, true. But to make sure, I'm going to use over here, I think a 10. I like 10. So substitute a 10. It's going to have 10 squared minus 8 times 10. And then is that a positive number? Well, 10 squared is 10 times 10, 100, minus 80. And then is 100 minus 80, which is 20. Is 20 a positive number? And that is true. So that means everything over here would make it true. And then finally, put your answer in interval notation. So we have this interval makes it true, and this interval makes it true. So this side would go from -infinity up to 0. So from -infinity up to 0. And this original problem did not have an equals, so that means use the round parenthesis. And then this interval goes from 8 to infinity. So from 8 to infinity. And then you just put a union in the middle, and that is that one. Now I just have one more. Uno más. Excuse me. So for the last example, suppose you have the function x cubed minus 4x squared plus x plus 5. And the question is, where is the function increasing? So increasing means it's going up like this. So basically this general shape, not this, that's decreasing, but like this, increasing. And in about 2 weeks, we can use calculus to do this. Right now, we're using the calculator. So let me go to y equals and clear out the old problem, and then x, and remember that this little up arrow right here is for exponents, so raise it to the third power. And if I continue typing, it's still up there in the exponent. So you need to go to the right so that it gets out of the exponent. And then minus 4x squared, and then plus x and plus 5. And then let's see what that looks like. So I'm going to go to zoom number 6. And the general shape of that one is it goes up until right about here. then it goes down, and then it goes up. So where is it increasing? So as you follow the graph, this is increasing until it gets to the top right there. Then it's decreasing, and then from this bottom point up, this is also increasing. So basically I need to know where's that point, because it was increasing on the left until it got to that point. The problem did not ask about the decreasing, and then from here it goes up. So this point right here, when it gets to the bottom, is called a minimum. When it gets to the top right here, that's called a maximum. And in the near future, we will be able to take the derivative and find out these points without a calculator. But at this point, we use a calculator. So go to second calculate, and as you can see, the maximum is right there, number 4. Then all you need to do is go a little bit to the left of it. So move a little bit to the left and hit enter. Then move to the right. Make sure that I'm definitely to the right of it. And then what's your guess for where the maximum is? My guess is it's approximately right there. And the calculator says that's when x equals a 0.131. And right now I don't need the y value because I just need to say to the left of 0.131, that's when it's increasing. Now let's find this one. So that is the minimum. So put second calculate, and then you guessed it, number 3, the minimum. And again, move until you are to the left of that minimum. And it doesn't even have to be that close, like right here. And move to the right of it. And again, it doesn't even have to be that close, like right there. I'm not being very accurate at all. And then where do you think the minimum is? I think it's right there, which is a horrible guess because it's supposed to be down there. But watch what happens. That calculator is so smart. So it turns out that x equals a 2.535. So this is happening at 2.535. So for increasing, which I often just abbreviate as increasing, so that's the left side. So when x goes from negative infinity until it gets to right here, then the graph has been going up. So from negative infinity to 0.131. Now when it gets to that point, it's not going up anymore. So that means that this needs to have a round parenthesis. And then the right side, so from 2.535 until x goes out forever, so from 2.535 out to the right forever, put a union, and then that's where it's increasing, and that's the end of today's video.